discussing lesson 14, and in lesson 14 we are going through the topic effects of electric current. So children, we have already discussed about what is an electric current. Can anyone define what is an electric current? Yes, Yana?
Ma'am, electric current is the current through which the electricity flows, or and the circuit through which the electricity flows is called circuit.
Yes.
The path of electricity where electricity flows.
Electricity flows. Same thing. Electric current, electricity flows. What is actually flowing?
Electrons.
Electrons. The flow of electrons constitute electric current. Now we are going to study what are the effects of electric current. Alright? So children, you know that an electric current can generate three effects: heating effect, chemical effect, and magnetic effect. To begin with, we will start with heating effect. To demonstrate heating effect, I will show you a simple activity. See, I have taken a battery and I have taken a piece of aluminium foil. Now, if I connect aluminium foil to the two terminals of the battery, like this, so a simple circuit is formed. Now, if I represent this circuit like this, will you agree with me? I have taken a cell or a battery. Can I represent the cell like this?
Yes, ma'am.
Positive terminal and negative terminal.
Yes, yes.
And I have connected these two terminals using an aluminium foil. Isn't it? Now the circuit is complete. The electric current will flow. You know? Now, when electric current flows, what is the function of this cell or the battery in this circuit? To push. Yes. It is providing a force to push the electrons. That is, work is done on electrons to make them move from one position to another. Now, when work is done on electrons, this work done is converted into heat energy. If I hold this setup for some time, you will find that the temperature of the aluminium foil raises. Can you hold it for me? And after some time, if you touch and feel, you will see that the temperature of the aluminium foil raises. It shows that when electric current flows, it generates heat. So this is called heating effect of electric current. Now, this effect of electric current finds application in many areas. Can anyone name? Yes, Hannah?
Ma'am, electric iron geysers also.
Yes. Most of the electrical appliances that are used in our homes, electric heaters, yes, iron, yes, ovens, heaters, geysers, isn't it? Blowers, all these electrical appliances use heating effect of electric current. Now, to name the simplest electrical appliance that uses the heating effect of electric current is heater, or even the simple example is bulb, an electric bulb. Alright? I have drawn a very simple diagram of an electric bulb. All of you know that there is a filament in bulb. This filament is made of tungsten. Tungsten is an element. Yes. We use tungsten to make an electric bulb because it has very high melting point. On passing the current, the filament does not burn, rather it glows. And there is argon gas filled inside the bulb. Can anyone
Ma'am?
Yes, Meenakshi?
Because argon is a non-reactive gas, so it question.
ma'am.
Yes.
And argon is not a supporter of combustion.
Very good. Argon is
Don't.
an inert gas and it does not let the filament burn. Alright, that is why argon is filled. Okay. Now, children, all of you know that in our homes, lot of electric circuits are used. We are using fuses, electric fuses in our homes. Can anyone tell me on which principle does electric fuse work? Yes, Suraj.
Ma'am, fuse works on the heating effect of electric current
Yes.
as a thin wire of copper or some conductive material is made and a glass tube is there, and so it controls that there is not too much electric flow of electrons not too much electrons are going through.
Yes. In
And
case of in case of
that-
overloading, all right. When too much of electric current is drawn,
The
short circuit can happen.
And
So we
evaporate.
use so we use electric fuse which has a ceramic covering and it has 2 points where the wire is joined. Now, when a very thin wire with lower melting point is used, so whenever there is excess of current in the circuit which can harm our electrical appliances, so whenever there is extra load of electric current in the circuit, the fuse wire melts and breaks the circuit so that large amount of electric current does not flow in the electrical appliances. But what is the disadvantage of electrical fuse?
We have to put fuse once it is used.
Yes.
And it's a tough task.
Yes, it is a tough task to repair fuse again and again. So to overcome that disadvantage, nowadays we use MCBs. Can anyone tell me the full form of MCB? Miniature circuit breakers. Alright, in MCBs, what happens? There is a switch. Whenever there is extra load of current, the switch is put off. And to resume the electric current in our homes or to resume the
We have to
electricity, we
switch
only
it
have
on.
to put the switch on. Alright, so this was all about the heating effect. Now we shall start with the magnetic effect of electric current. There was a scientist named Hans Christian Ørsted. He was the first one to show that whenever electric current passes through a circuit, a magnetic field is generated. Alright? Magnetic field is generated. And the strength of the magnetic field depends on the strength of the
Current.
electric current that we are passing.
Ma'am,
Yes.
that is how electromagnets are made.
Yes, that is how electromagnets are prepared. Alright. Now, since you have used the term electromagnets,
Ma'am, can iron become electromagnet?
yes. Can anyone tell me what is an electromagnet?
Ma'am,
Yes, Lakshya.
Ma'am, it is a magnet created by using electric current.
Yes, it is a Alright. So, an electromagnet is made by winding around a metal wire around a magnetic substance. For example, we can take an iron rod or a steel and wind around it a copper wire and then connect both the ends of the electromagnet, both the ends of the copper wire with the battery. When we will pass the current will generate, the iron rod will start acting as a magnet. Alright, when we will switch off the
And we
current,
have to
there will be no magnetic field. Alright, I'll show you through a diagram. Suppose we take an iron nail and wrap it with a copper wire in a coiled form and then connect the two ends of the copper wire with a battery and a switch. When this switch will be put in on position, then current will flow through it and this iron nail will start acting as a magnet. Now, since this is acting as a magnet under the influence of an electric current, this is called an electromagnet. Now, when I will put the switch in off position, now no current is passing through the circuit, the iron nail will not act as a magnet. Alright? Okay? So, that was my next question. So, according to you, an electromagnet is a permanent magnet or a temporary magnet?
Temporary.
It's a temporary magnet because it acts as a magnet only
When
under
there
the
is
influence
no
of an electric
Ma'am,
current.
all the metals can be made electromagnet.
The metal has to have the conducting properties. Unless and until it is a good conductor of electricity, electricity will not flow, then how the magnet will be formed.
That
Alright.
silver is also electromagnet.
Silver can be used to make
But
an
it is
electromagnet.
expensive.
Yes, but silver is expensive, so we do not. So I will show you a video on Tataclass.
The magnetic effect of current. In 1820, Hans Christian Ørsted, a Danish scientist, studied the relationship between electric current and magnetism, observing that when an electric current is passed through a conducting wire, a magnetic field is produced around it. We'll recreate his experiment to illustrate how a current-carrying wire produces a magnetic field. To begin, we'll build a circuit using switch, a battery, and two pieces of wire. Connect the ends of one wire to one end of the switch and the positive end of the battery. Connect the ends of the second wire to the opposite end of the switch and the negative end of the battery. This will create a complete circuit. Using two small pieces of wood, suspend one of the wires so that it is about 2 inches off the table. Next, we'll place a compass below the wire. When the switch is in an open position, it will prevent current from passing through the wire. At this point, there will be no deflection of the needle.
In this condition, when no electric current is passing through the circuit, the magnetic needle will be pointing towards the Earth's north pole, isn't it? Earth's magnetic north pole. But when current will flow, see what will happen.
Meaning it will point as normal in the north-south direction of the Earth's magnetic field. Now switch on the electricity in the circuit to allow the current to flow in the wire. A current will pass in the wire from the positive end to the negative end, say from point A to point B. In the compass, the needle will now deflect towards the west.
So understood, children? This simple activity shows that deflection in the compass needle represents that when electricity passes in a circuit, it creates magnetic effect. Alright, magnetic field is generated whenever electricity passes through an electric circuit. Alright, so now just like heating effect has many commercial applications, similarly magnetic effect of an electric current also has several applications, commercial applications, which are used in day-to-day life. Can anyone tell me one? electromagnets?
Ma'am, in Begos, electromagnets are used to separate the soil and other particles from iron.
Yes. And tell me the very common example, very common
Electric fan.
electric bell. Electric bell is the most common example where
The electromagnetic axis.
where electromagnets are used, and how electromagnets are made by the magnetic effect of electric current. So now I'm going to show a video on Tataclass that how electromagnets are used and what is the working of an electric bell.
Electromagnet sounds like a fancy name, doesn't it? But it's really simple. When a wire is coiled around a piece of iron and current is passed through it, the iron core behaves like a magnet. This is an electromagnet. So how is it different from a permanent magnet? An electromagnet is a temporary magnet that can be switched on and off by controlling the current flowing through the coil. Interesting, isn't it? We can also alter the strength of the magnet by changing the number of turns in the coil or the amount of current passing through it.
Now, this is an important point to be noted, children, that the strength of electromagnetic can be increased or decreased. How and what are the two factors which play a role in controlling the strength of magnetic field? Is the number of turns in the coil. If we increase the number of turns in the coil in an electromagnet, the strength of magnetic field will increase. And if we increase the strength of the current passing through the circuit, then also the magnetic field can be, a stronger magnetic field can be generated. Alright?
This makes it suitable for various purposes.
Now, I'll show you how an electric bell works. Electric bell uses electromagnet and is based on the magnetic effect of electric current. So, I'll show you how it works and what is the principle behind it.
We hear the school bell often. But have you ever wondered how it works? Let's find out.
Now see, this is the circuit of an electric bell.
These are the parts of an electric bell. It has a wire coiled around a piece of iron, a gong, a soft iron strip with a hammer, and a contact screw close to the iron strip. When the bell is switched on, current begins to flow in the circuit. When the current flows through the coiled wire, it turns the piece of iron into an electromagnet which attracts the iron strip. When the iron strip moves closer to the electromagnet, the hammer hits the gong and produces a sound. In the process, the iron strip moves away from the contact screw. This breaks the circuit and current no longer flows through it. So what happens to the electromagnet? It is turned off. And the iron strip springs back to its original position, touching the screw. The circuit is complete again and current flows through the coil. attracts the iron strip and the hammer hits the gong again. This cycle keeps repeating itself and the bell rings until it is switched off. Isn't that an interesting way to use the magnetic effect of electric current?
Children, have you understood the construction of the electric bell as well as the working of the electric bell? Now, this is your homework that you have to find out that where electromagnets are used, that is you have to find out other commercial applications of electromagnet. One we have discussed, that is electric bell. One more I'll tell you. Yes, Rishita? Electric fan. Anyone else? Anything more which can really with which we can really correlate with the topic? Telephones, yes.
Fire alarms.
Fire alarms, yes. Speakers and
Microphones.
how electric comes? See, all of you have read about separation techniques. You know? We have electromagnetic lifts to separate magnetic substances, or you can say magnetic waste material in scrapyards. Alright, so can anyone think of the reason why we are using electromagnetic lifts? To lift the magnetic waste, yes?
Ma'am, because even if we are not using the machine, then also it will attract the scrap.
So, do we only need to attract the scrap?
No, we have to put it down.
So we have to put it down. Since we have to separate it from the mixture of, since we have to segregate it, so we have to lift it also and put it down also. So that is why we are using electromagnet. Okay. Now, the third thing that we are going to discuss is chemical effect of electric current. To study chemical effect, again I am drawing a setup, I am drawing a diagram to explain. I have taken a glass jar. I have taken two metallic rods. I have connected these two metallic rods with the battery, and this glass vessel is filled with an electrolyte. Electrolytes are the substances which break down into their constituents on passing electric current. I will first of all take the easiest example, that is water. H2O. All of you are aware of the chemical composition of water. It is a compound. Its formula is H2O. Now, if I add some acid in it and pass the current through this setup, water will dissociate into hydrogen and oxygen. Okay? Water will dissociate into hydrogen and oxygen. Okay? This will form hydrogen gas and this will form oxygen gas. Alright, so what is happening? We are passing electric current and a chemical compound is breaking into its constituents. That is, and all of you know that in a chemical compound, the constituents have different properties. So what we are doing? By passing electric current, we are changing the chemical properties of a substance. If water breaks into hydrogen and oxygen, then the properties of water are completely different from the properties of hydrogen and oxygen. So, from this we come to know that electric current also causes chemical effects. Alright? Instead of water, we can take different electrolytes like sodium chloride, okay, common salt. We can take copper sulfate, CuSO. Alright, and this whole process is known as electrolysis. Alright, and this setup is called electrolytic cell. Alright, so now I'm going to show you a video on the same.
We all know that a water molecule is made up of 2 parts of hydrogen and 1 part of oxygen. That is H2O. But can we pull the oxygen atoms away from hydrogen atoms? Maybe not physically, but there is another very simple way. If you want to break apart a water molecule, you will need a glass beaker, water, salt, carbon rods, 3 electric cells with a combined potential difference of 6 volts, a switch, connecting wires, and a piece of cardboard. Let's begin our experiment. Click on the empty beaker from the list of apparatus on the right. Now, fill water in the beaker. Click on the beaker filled with water from the list. Next, add salt to the water. Click on salt from the list. Pure water is a bad conductor of electricity. Adding salt to the water increases its conductivity and speeds up the splitting process of water. Now immerse both the carbon rods in the salt solution. These will act as our electrodes. Click on the carbon rods to use them as electrodes. Next, connect the electrodes to the battery and the switch. Click on the cells to make the connections. Now, let's turn the switch on and let the current flow through the circuit for 15 minutes. Click on the switch to turn it on.
Ma'am, that switch.
Now observe the electrodes carefully. Do you see the water bubbling near the electrodes? What's happening? Let's find out. When you switch on the circuit, electrons flow from the negative terminal to the cathode. The hydrogen component in the water molecules accepts these electrons to form hydrogen gas. At the same time, the oxygen component of water gives away its electrons to the anode to form oxygen gas. These electrons go back to the battery, completing the circuit. So to split water into hydrogen and oxygen, all you have to do is pass electric current through it. This process is called electrolysis. To check if the gases formed at the electrodes are hydrogen and oxygen themselves, we can do a small experiment.
we have covered all the 3 effects of electric current today. Go through these topics at home, and tomorrow we will be discussing the enrichment sheet of this lesson.